Welcome to Algeomulus Prep Academy. The lesson for today is the mean value theorem. The definition of the mean value theorem is if f is continuous on the closed interval a to b and differentiable on the open interval a to b, then there must exist at least one point c such that f prime of c is equal to f of b minus f of a over b minus a, where a is less than c, which is less than b. Now let's look at this graph. Here on the interval a to b, since the function is continuous and differentiable on the bound, there must exist a point c where the instantaneous slope at that point is equal to the slope of the secant line between a and b. How you find the slope of the secant line is just like taking the slope of any other 2 points. You take f of b minus f of a and divide it by b minus a. If this is equal to the instantaneous slope at point c, then the mean value theorem applies.
For your first example, apply the mean value theorem to f of x is equal to 2x cubed plus 3 on the interval 0, 3. First, write out your equation. Then, find f of b and f of a using the interval values. Next, find the slope of the secant line on 0, 3 using f of b minus f of a all over b minus a. You should get 18. Next, check for differentiability. F of x is a polynomial, so it is automatically differentiable on the interval 0, 3. So, the mean value theorem applies. Next, take the derivative by using power rule. Bring 3 down and subtract 1 from the power. You should get 6x squared. Set f derivative of c equal to the secant line slope on 0, 3. Then, plug in your numbers. Solve for c by dividing both sides by 6 and square rooting both sides. C should be equal to plus or minus square root of 3. However, c has to be on the interval 0, 3, so only positive square root of 3 works. So, c is equal to square root of 3.
For this problem, we are given that f of x is equal to the square root of 4x minus 3 on the interval 1 to 3. We need to find a point c such that the average rate of change on 1 to 3 is equal to the instantaneous rate of change at c. This requires the mean value theorem, which, if applicable, guarantees at least one point c within the bounds a to b, or in this case, 1 to 3. First, we need to check for differentiability and continuity. F of x is a square root function and is differentiable and continuous after the point at which f of x is equal to 0, which we can solve for to find that x is equal to 3/4. The bounds are within x is greater than or equal to 3/4, so the mean value theorem applies. The mean value theorem states that f prime of c, or the derivative of f of x at point c, which will be the instantaneous rate of change, is equal to the average rate of change over a to b, or f of b minus f of a over b minus a. First, we need to derive. F of x is equal to the square root of 4x minus 3, and to derive square root functions, we can use 1 over 2 times the square root of u times the derivative of u. In this case, u is the 4x minus 3. So, we can derive to get 1 over 2 root 4x minus 3 times 4, or when we simplify, 2 over the square root of 4x minus 3. Now we can set up the mean value theorem equation. Plug in c into f prime of x to get 2 over the square root of 4c minus 3, and then plug in our bounds to get f of 3 minus f of 1 over 3 minus 1. 2 over the square root of 4c minus 3 is equal to f of 3 minus f of 1 over 3 minus 1. Now, we can plug the values 1 and 3 into our f of x to find the top part of the average rate of change in the numerator. 2 over the square root of 4c minus 3 is equal to the square root of 4 times 3 minus 3 minus the square root of 4 times 1 minus 3, all over 3 minus 1, which is 2. 2 over the square root of 4c minus 3 is equal to the square root of 9 minus the square root of 1 over 2, or when simplified, 3 minus 1. So 2 over the square root of 4c minus 3 is equal to 3 minus 1 over 2. We can simplify the 3 minus 1 to 2 to get 2 over the square root of 4c minus 3 is equal to 2 over 2, which would simplify out to be 1. So 2 over the square root of 4c minus 3 is equal to 1. Multiply the denominator of the square root to both sides to get 2 is equal to the square root of 4c minus 3. Then square both sides to get rid of the square root to get 4 is equal to 4c. Add the 3 to get 4c is equal to 7. Then divide by 4 to get c is equal to 7/4. This is our point c within the bounds 1 to 3 of f of x. Now we need to verify the point c. C is equal to 1.75, and 1.75 is greater than 1 and less than 3, so C is within the bounds. This value works. Now we can graph to check our point C. This is the graph. The secant line connecting f of 1 and f of 3 has the slope equal to the average rate of change on 1 to 3. The tangent line at f of 1.75 has the slope equal to the instantaneous rate of change of f of x at the value x is equal to 1.75, which is the c value we just found. This is the instantaneous rate of change. As per the mean value theorem, the lines are parallel, meaning the instantaneous rate of change is equal to the average rate of change, as demonstrated by the slopes of the secant and tangent lines.
For f of x is equal to x minus 1 plus 1 on the interval 0 to 2, find point C such that the average rate of change on the interval 0 to 2 is equal to instantaneous rate of change at point C. This requires mean value theorem, which, if applicable, guarantees at least one point C within bounds a to b. First, check for differentiability and continuity. We know absolute value functions are not differentiable at one point, so we should check first by deriving as a piecewise function. We can split f of x is equal to x minus 1 plus 1 into a piecewise function, x minus 1 plus 1 when x is greater than or equal to 1, and negative x minus 1 plus 1 when x is less than or equal to 1. We can also take the derivative here. To check for differentiability, we should find the point at which f of x is undifferentiable, the vertex. By definition of absolute value function, the vertex is at hk or 1, 1. Since 1 is not equal to negative 1, we know the function is not differentiable at f prime of 1. Graph and bounds show x equal 1 is within 0 to 2, the established bounds. As established earlier, f prime of 1 does not exist. F of x is not differentiable at x is equal to 1. Because f of x is not differentiable at a point within 0 to 2, the mean value theorem is not applicable.
Thank you for watching this video on Algae Omnilus Prep Academy.